So take the opportunity at the beginning of the video to pause it, have a look through this question and perhaps answer it yourself so that you've got your answers to compare when I go through the question. Okay, so we've got another calculation question here, but again, it's got some ideas that we need to make sure that we're using confidently. So let's get started. When an object is moving, it is said to have momentum. Define momentum. So define questions are talking about specific quantities. So let's think about what we know about momentum to start off with, where we know that momentum equals mass times velocity. Okay, so this in itself is pretty much a definition, but we can actually sort of write this in words in that it is the product of mass and velocity. So the product of mass and velocity. So it's always worth thinking about what is the equation and then seeing if you can actually put the equation part in words. So for example, if you've got something over time, that's the rate of that quantity. So the equation for current is I equals Q over T. This is a bit irrelevant, so let's just leave it to one side. I equals Q over T. So because it's over T, that means rate. So if it said define current, then I could say the rate of flow of charge, and that would be the definition. It might be the case that you get the mark for just giving the equation, but just in case you don't, it's always worth writing it out in words as well. Okay, so let's move on. We've got a nice big diagram here. So there's obviously going to be some juicy bits of information. So the diagram below shows one way of measuring the velocity of a bullet. Okay, so we've got a diagram. Make sure again that you look at these diagrams. Don't just ignore them and jump straight to the bit that's actually asking you to do something. So it's telling us here that a bullet, this is the bullet, and this is 20 grams. And then this is a block of wood, as it's labelled here, and this is before the impact, and then after the impact, and it's got the bullet lodged into it here. And it tells us 3,980, oh, there should be a decimal point there, 3.980 kilograms. Okay, I think my printer's not great, sorry. Okay, so this looks like it might end up being quite a complex calculation. So something that we can do is we can start a list of information that we know. So let's pick a nice bright colour that's going to stand out. So we know that the mass of the bullet is 20 grams. Whenever something's given to you in grams, I would always convert it straight away into kilograms, because we don't use grams as a unit. So it's 0.020 kilograms. Then it tells us that the mass of the block is 3.980 kilograms. So we can start this list off, and then as we get given bits of information, we can add to this list, and I'll show you later why this becomes quite important. So let's leave that pen there. So a bullet is fired into a block of wood suspended by a long thread. The bullet stops in the wooden block. The impact of the bullet makes the block swing. The velocity of the wooden block can be calculated from the distance it swings. In one such experiment, the block of wood and bullet had a velocity of 2 meters per second. So the block of wood and the bullet had a velocity of 2 meters per second immediately after impact. Okay. Oh, that should have been purple, but never mind. The mass of the bullet was 20 grams, and the mass of the wooden block 980 kilograms. So we've got quite a lot of information here, and then it's going to start asking us questions. So let's look at this first question. Calculate the combined mass of the block of wood and the bullet. Okay, so I mean, you could use a calculator for this, but we're not going to need to. 3.980 is the mass of the wooden block. and we are adding it because it's the combined mass. We're adding it to the mass of the bullet, which is 0.020. 0.020. Hopefully we can all do basic addition, and we know that the mass is therefore going to be 4 kilograms. I would even go as far as writing 4.000 kilograms because it's given it us to 4 significant figures. So therefore this tells us that we actually know that it's 4 kilograms to 4.000 kilograms. Okay, so that's kind of just easing you into the swing of it, really. So the next bit then says calculate the momentum of the block of wood and bullet immediately after impact. Okay, so we have already written down our equation up here, so we can write that again up here. So the equation we want to use is momentum equals mass times velocity. Our mass we've already calculated is 4.000, and the velocity, it already told us here, was 2 meters per second, which we can actually add to this list here. So velocity of both is 2 meters per second. Okay, so we're adding to that list as we go. So again, we don't really need to get the calculator out. So if we do 4 times 2, then that's going to give us 8. So that's 8, and then the unit kilogram meters per second. So therefore we can add to this list here, momentum of both is 8 kilogram meters per second. So keeping this running list is going to be really helpful to us as we go through. Okay, so then the next bit tells us to state the momentum. So note that it hasn't told you to calculate anything. You've just got to state it. So state the momentum of the bullet immediately before the impact. Okay. The fact that it's 1 mark and the fact that it says state is a clue that you're not actually going to do a calculation. Okay, so let's think about logically how we already know this momentum. We know that the momentum of this bit after the impact is 8 kilogram meters per second. So that's the momentum P. Momentum is mass times velocity. So if the velocity is 0, so if something's stationary, then it's going to have 0 momentum, because no matter what its mass is, something times 0 is 0. So 0 velocity, 0 momentum. The block was stationary to start off with, so therefore its momentum was 0. And because of conservation of momentum, as in whatever the momentum is, combined momentum is before, has to be the combined momentum afterwards. Well, the combined momentum before is 8. We know that this is 0 kilogram meters per second. So therefore, something plus 0 is 8. Well, therefore, the bullet has to be 8 kilogram meters per second. So therefore, stating the momentum, we're just stating the same answer as before, 8 kilogram meters per second. Okay, so then the next question. So calculate the velocity of the bullet before the impact. So we're now being asked to find just the velocity of the bullet. So let's think about the information that we have about the bullet. Well, we know that the momentum of the bullet is 8 kilogram meters per second, because we've just written that down. The momentum of the bullet is 8 kilogram meters per second. And we know that the mass of the bullet is 0.020 kilograms. Okay, which means that we can still use this equation, but we're just going to rearrange it. So rather than writing all the words out, I'm just going to write P equals mv. So P is momentum, m is mass, v is velocity. And then underneath there, we're going to write 8 because that's what the momentum is. The mass is 0.020, and then V is what we want to find out. So at the moment we've got 8 is 0.020 V. We want to find out what V is by itself. So we need to divide this side by 0.020, which means we also need to divide this side by the same number. So if we get the calculator, 8 divided by 0.020, then we get 400 is our velocity. So 400 meters per second is the velocity of our bullet. Okay. So we can then add to our list here. Velocity of the bullet is 400 meters per second. Okay, so next question. Calculate the kinetic energy of the block and the bullet immediately after impact. It's really important that you look at the values that you're actually being asked to use. So it's really important whether you're looking at just the bullet, just the block, or the block and the bullet together, because that's obviously going to have an impact on the quantities that you use. So calculate the kinetic energy. Well, kinetic energy is the quantity we're calculating. So we need to write out the equation for kinetic energy, which is 1/2 times mass times velocity squared. So 1/2 is just 0.5. The mass of the block and the bullet, if we go back to here, is 4 kilograms. And then the velocity of the block of wood and the bullet, so the velocity of both, is 2. And then the 2 is squared, so it's just that bit that's squared. So we can then work that out. So 2 squared is 4 times 4 times 0.5. So therefore the kinetic energy is 8 joules. So I would still write that in here, even if you've written the correct answer there. Always make sure that it's there. It's really easy for your examiner therefore to see that they can give you a mark. Okay, so that's the end of the calculation part of it, but we've still got one more question, and it's only worth 1 mark, but it's still important to answer. So the kinetic energy of the bullet before the impact was 1,600 joules. Okay, so the kinetic energy of the bullet was 1,600 joules. This is much greater than the kinetic energy of the bullet and the block just after the impact. What has happened to the rest of the energy? So if it's 1 mark, you're really only looking for like a keyword or a key phrase here. You're not expected to give a huge amount of detail. So be careful that you're not going to spend ages on a question like this that's really only 1 mark. So what has happened to the rest of the energy? Well, not all of it has gone to moving the block. Some of it will be transferred to other stores. So you could say that it is dissipated. That's a good keyword that they like you to use when you're talking about these energy transfers. You could say that it is transferred to thermal energy store. And that could be the thermal energy store of the surroundings, it could be the thermal energy store of the bullet, it could be the thermal energy store of the block, or you could talk about that there is some sound, because obviously it would be quite loud, even with the impact of the block of wood.